Hello and welcome to my channel. Today I'm going to show you how you can build your own personal VPN server for just about $5 a month. There are a lot of free as well as paid VPN service providers, and you may wonder why build your own. Well, there are a couple reasons. One, you don't know what they do with your data when you subscribe for a VPN service from third-party providers. Two, if you are like me, you would want to build things on your own and learn along the way. And third, you can be certain that when you use your own personal VPN server, no one else has your browsing data. At least that goes through the VPN. So for these and a couple other reasons that I haven't talked about, you would probably want to have your personal VPN server. Even if you don't, it's pretty cool to just learn how to do these kind of things. So let's get started into some of the details and discussions before we actually head into the lab and actually create a real personal VPN server. There are a couple different choices when it comes to building your own personal VPN server. You could use PPTP, you could use OpenVPN, or WireGuard, and there are probably tons of other VPN software or VPN applications that you could use to build your VPN server. But I chose WireGuard for this particular video tutorial. I've done a lot of PPTP and OpenVPN in the past. If you would like, just let me know in the comments and I will create yet another video on those particular VPN servers. But WireGuard seems to be like the latest and greatest, and everyone's widely adopting this application. So I just decided to create this video with WireGuard as the choice for the VPN server. It seems to be pretty fast too. So why even WireGuard? It seems to be extremely fast, simple, but modern VPN. It is designed as a general purpose VPN and supports a multitude of platforms, including embedded interfaces. So you can install WireGuard on OpenWRT, you can install WireGuard on Linux, you can do Windows, you can do Mac. It supports a number of clients, Android, iOS, and all those different platforms. So obviously it's cross-platform. It is really under heavy development. It is very, very simple and easy to deploy. We're going to see this when we build this server. It's pretty simple. Once you understand what the configuration and all that, the installation and configuration is really simple. So in order to do the installation, let's just look at the high-level steps that are involved. We're actually going to be doing this in the lab. You have to install the kernel headers so that, when you install the WireGuard, it can compile the module. You install the EPEL repo. We're actually talking about the installation on CentOS platform. I'm going to put a link to my blog where I also talk about how to install in the Raspberry Pi, and then I may update those with other Unix distributions as well. But for now, in this video, we're focusing on the CentOS 7. So we'll talk about how the installation looks like in terms of the CentOS operating system. Like I said, you install the kernel headers for the WireGuard to be able to compile the module. You install the EPEL repo so that you can install WireGuard package, and you just install the WireGuard and QR encode package. The QR encode package will let you create those QR codes from the configuration file so that you can scan that in your mobile device and don't have to necessarily copy the config file. That's pretty simple, right? I mean, that's how the installation looks like. Then there comes the configuration. Once you have the WireGuard installed, then you create the keys for the server. You create the configuration file for the server. Then you create the client keys. So you would do this for the number of, however many clients you have, you would have to create the keys for all those different clients. Then you create the configuration file with the keys and some other additional configuration points, which we will talk about. And then on this server, on the VPN server, you enable IP forwarding so that you can forward the traffic from the VPN connected clients out to the internet. Then we just QR scan the client config or just copy the config file to the client device and then connect, and we enjoy the VPN. That's the high-level overview. The website for the WireGuard is just wireguard.com, and then you can read about it on the website as they talk. It's simple and easy to use. cryptographically sound, minimal attack surface, high performance, well-defined, and thoroughly considered. And you can look at the what are the concepts behind, and they also do the crypto key routing and all that. You can just look at, the details if you wanted to learn more about WireGuard. We have done some tests, and then it actually seems to be faster than OpenVPN. I do not want to comment on the security because I don't necessarily know which one is more secure. I guess both are secure, but I just don't want to comment on that. That's it for the high-level overview and general information. Let's head into the actual configuration and deployment part. I'm logged into my DigitalOcean account. You can use any provider. I will just go ahead and create a new droplet. I will choose CentOS 7 standard, and I'm just going to do the $5 per month. Nothing much to do. I could select San Francisco is closest to me. VPC. I'm just going to destroy this once I'm done, so I will just use the password. Otherwise, I would have used the SSH keys. It's more secure. Then we're going to create the one droplet. The name doesn't really matter here. You could put your name if you would like, the host name. When you build it, if it's going to be permanent, you probably want to point your DNS to this IP and all that. But for now, I'm just doing this for this video, so I will just go with the quick options here. Cannot end in a number or a special character. That's weird. Never seen that before. Okay. First and last characters don't count. Okay, that's a little tricky. Let me just come up with some password that meets that requirement. Okay, that will do. And don't need the backups, user data monitoring. I don't need anything else. So just just looking, reviewing this, CentOS 7.6 standard plan, starter $5 per month, San Francisco, and that's it. We're gonna create the droplet. Do we have the IP yet? Okay, we have the IP. So let me just open up PuTTY. Still in process. Okay, the droplet has been created. So we'll log in here. Okay, copy the password. Okay, I'm in. All right, so we are inside the CentOS operating system. So first we will, when you are actually building this for production use, for your personal long-term use, you might want to update all the packages before you start doing this, but I'm going to skip that for now. We are going to install kernel headers and kernel development packages. In order to perform the installation, you could just go to the wireguard.com, and if you look at the installation here are various different installation methods. So for Windows, you just have the binary. For Mac OS, you have the binary and all that. We're interested in CentOS 7, so we'll just scroll down. You could similarly do the CentOS 8. I have not done that yet, so I'm just sticking with the CentOS 7 for now. Then we will just copy and paste these 3 commands. Copy that. Install the Apple repo. Say yes. Then the next is to install the Yum plugin repo. We'll do that. And finally, we just have to install the kernel module and the WireGuard tools. Okay. You have to ensure that you have installed the Linux kernel headers and the development package before you install the kmod WireGuard, because it uses those sources to compile the WireGuard kernel module. Okay, it's installing the kernel module. It does look like it is also installing the kernel 3.10. I did not check what kernel we were running before. Can take some time. So the installation is now complete. Let me clear ls mode, grep -i, WireGuard. There's nothing. Uname -a. So we're running 3.10. Let me see, what was the kernel? 3.10.0.11.27. Okay, so it does look like we're going to have to reboot the box in order to boot with the new kernel. Let me just capture that. Or just take a snip of that. What happened to the snipping tool? All right, let me just take a snip so we can compare once it reboots. If it was the same kernel version, you could probably just do the mode probe. And also there is another way to validate this if the kernel module is loaded, is IP link add dev wz0, and you can say type WireGuard. So if you get this RT netlink answers operation not permitted, that does mean that there is no kernel module loaded that supports the type WireGuard interface. Mode probe, you could otherwise, if it was the same kernel, you could have done mode probe and then WireGuard. So, sorry, mode probe. Yep, module WireGuard not found. It's in the newer kernel, so we reboot, and I'm pretty sure we'll be able to load that kernel module. Give it a minute to reboot. All right, let me copy the password. And I guess we didn't need this snip. I can just do uname -a. And as you can see, the previous kernel was 3.10.0.957, and this one is 3.10.0.11.27. Now if we do ls mode and grep -i wire, oh well, wz maybe? Okay, I don't know what's the name, so we'll just do this. And as you can see, whatever the name of the kernel module is, it does let you create that WireGuard type interface when you have the right kernel module. And if you do fconfig -a, you will see the WZ0 interface there. Because we are going to use the systemd to manage this, we are going to remove that interface. We just did that in order to validate that the kernel module has been loaded. So we'll say del dev wz0. Okay. And if we do this, we don't have that interface anymore. Let me now clear the screen. Also, I just thought that when we did the ls mode, because the module was not loaded, we didn't see WireGuard, right? When we did issue the IP link add command, then the kernel module got loaded, so we should be able to now see the WireGuard module. So as you can see here, that the WireGuard module is now loaded. You could have just done mode probe WireGuard after that. All right, so you could also do rm mode WireGuard to remove that. So ls mode, rm mode, okay. Oh, I'm sorry. Yeah, it's not the E at the end. So you unloaded this. Now, if you look at the ls mode, then you wouldn't see that, right? So now, back to the original situation where we were trying to do the ls mode, we don't see the WireGuard is not loaded. Now you could load it with mode probe, and then WireGuard is the name of the kernel module. So now if we do the ls mode, we can see that the WireGuard module is loaded. Just wanted to clarify that. So now with everything in place, we should go inside the etc WireGuard directory, which is where we'll put all the configuration. The first step is to create the server keys, and we want to start by changing the UMask to 077 so that the file when created is read only by root user. Let me see if they have anything here. Yeah, so it's right here on their website. You could just follow that, or you could just follow along with me. So you can find all the information on their website. It's pretty easy and simple to use VPN server. Okay, back to this here. In order to perform the installation, we start by doing the UMask 077. UMask, will change that to 077. I believe the root's UMask by default is 022. It could be wrong. Let's just search real quick. Default UMask set 07 for root. Okay, yeah, so the default UMask for the root user is 022. Here we already did the UMask 077, so I should have checked that before. You can just run the UMask command to check that. So it's 077 for now. So what this does is all the files that are created moving forward, it will set the ownership to root, and then it'll change the permissions to read write only by root user. Now let's go ahead and create the keys for the server. You could do this in one step or two steps. So you could do gen key, you could t that and say private.key, pass it to wz pub key, and we'll say server-public.key. So this way you have two keys, and then as you can see here, these files are RW only for root user. Now if I wanted, I could do this in two steps. I can generate another set of server keys. WZ zen key. What this does is generates the private key. So we can redirect to server2.priv or whatever, and then we can say wz pub key, and this expects a private key. So you pass the priv key, as you can see there, it'll generate that there, so we can redirect that to server2.pub. Doesn't matter which way you generate the keys, so I will just go ahead and delete those. Yep. So now we have the server private key and the server public key. Let's hold on to that. And now we are going to create the server config file. It is super simple. We'll just say wz.conf, or you can say wz server or whatever, or you can even say wz0.conf, let's say, because that's the first one if you wanted to create multiple WireGuard instances. You have two blocks here, an interface, and there's the peer. So what happens is on the interface you define and you configure the server side options, and on the peer section you define the client configuration. So here we will say address equals. So now we define what is the network address that we want to do, right? So let's say 192.168. I'm going to say 78.0, or I could just say 200.0/24. That's the network. Oops, sorry. It has to be the address of the tunnel server. So we'll say 254, and that's that. And we will say save config equals true. Now we have to define like two firewall rules so that the NAT happens on the client traffic, right? So we'll say post up. We'll do IP tables -a forward. You can hardcode the interface, or you can just say %i, so it is going to use whatever the interface name of the WZ0 in this case. We're going to say accept. So we'll accept anything to be forwarded from that interface, and we will, again, IP tables -a forward. We will forward, in the forward chain, we're going to forward that out of the tunnel interface, and we'll say accept. We'll accept the forward traffic in the interface and out of the interface is what this means. So now we will do the NAT post routing of that traffic through ETH0, if I'm not wrong. Yep, so whatever your WAN or the internet facing interface is. So you want to put that there. That's 0 in this case. And then we will masquerade that traffic. And we will do same thing when the interface is down. So post down will remove these rules that we created, right? So we could basically just copy this. We'll say this is when the interface comes down. So we will just have to delete instead of append. Okay, so that should be it. The next item we need to configure is the listen port. You can choose any port. There is no hard and fast rule. Just make sure the port is not in use already. Usually high ports are usually free. So let's say I'll say 55. So the maximum port number that you can use is 65535 as long as you are below that. And I recommend going above 1024 but below 65535, which is the maximum port number. So that's 55,525, which should be good with that. And here you put the private key for the server. So let's cat the private key. Server-private key. And we could just send it there. W0. Alright, so that's the server private key. And that's basically it for the server configuration. Now for the peer, we have to define two parameters, public key and the allowed IPs. Let's just create the public key, the keys for the client, and then we'll talk about the allowed IPs parameter. You just clear the screen. We'll just use the same command to generate the keys. We'll say client-private key and client-public key. On the server side, you're only going to configure the client public key, and on the client side, you're only going to configure the server's public key and the client's private key. So it's just, vice versa. So let's cat the client public key, client's public key into the wz0.conf. All right, so we'll say paste it here. Oops, my bad. Okay, so that's the public key for the client. And now on the allowed IPs, you would put the IP address that you want to assign to the client. So let's say, for example, 192.168.200.5 and /32. So that /32 defines that the 200.5 is the IP address that is going to be assigned to the client. This is how you configure the client on the server side. If you needed to create additional clients, you would repeat the process. You would generate the new set of keys, the private and the public for the new client, and then you would create another peer block here, like this. Peer block here, you would put their public key in here, and then you would add the allowed IPs, for example, 200.10 or 6/32, whatever the IP that you want to assign to. In this example, we're just going to talk about one client. So we just have that. So I'll go ahead and remove that. So now the server side is pretty much configured. On the client side, let's say client01.conf or whatever meaningful name that you want to give for the config file. We have already generated the client keys. So on the client side, the client config, we will still have the similar configuration. So we'll have the interface and we'll have the peer, but the roles are flipped. This is the client configuration. So on this, you would put the client's IP address, 200.5/24 is what we're going to put because that's the subnet mask, is this /24. Then you would put the private key. Remember, we did put the private key of the server in the server config, but here we are going to have to put the client's private key. So cat client-public key. Sorry, the private key, because this is the client config. Private key here, client01. So on the server, you would put the server's private key. On the client side, on the client config, you would put the client's private key in there. Then you can define what DNS you want to use. For example, 8.8.8 or whatever DNS server you want to use on the client side. On the peer, we are going to configure the server information. So we'll say public key equals, and let's check the server-public key. So we have the server-public key. Oops, WZ dot, oh God, we're working on the client01.conf. So the server public key is there. Now allowed IPs. This is where you define what route do you want to push on the client. So you define this on the client side. You say if you want to do the full routing, you want to route everything to the tunnel, then you want to say 0/0, and then for IPv6 you would do this. If you wanted to, on the other hand, do a selective routing, or if you wanted to route only, say, 168.200.0/24 and 160 or 10.network, for example, 10.20.0/24 or whatever it is, you can separate, like comma separated list of network siders. And because we want to route everything through the tunnel or the VPN, we'll just say this /0. If you are not using IPv6, you don't have to, but I'm just leaving it there. Then you define the endpoint, which is going to be the server IP. Let's just look at what the server IP is. And also, what port did we define for the server? We said 55525. Okay, so we're gonna put here the server IP. 55525 is the port number. And the other configuration item that I wanted to talk about is the persistent keep alive. WireGuard recommends 25. I like to put 15. This is required when there is a router or a stateful firewall and you haven't sent any packets in the last X number of seconds or minutes at a certain interval, then the state is removed and then you may not receive the packets sent by the server. So in order to avoid that, you want to keep the connection alive by sending something every 15 seconds or so. So that's it for the client configuration. We still have another part that we need to do. Let's make sure the IP tables command work. We don't have to change the firewall, but let's just make sure the IP tables command work. Now we need to enable IP forwarding. In order to enable IP forwarding, we would have to, we can just say sysctl -a and then grep for forward, if just to make sure just to check if it is already enabled. So IPv4 IP.forward is set to 0. So what we're going to do is we're going to set that to 1 so that the kernel allows the forwarding of the IP traffic. In order to do that, you can just sysctl.conf. You can put that configuration here, or you can put that in etc sysctl.d, and then you can say, for example, WireGuard.conf. That way, you have the configuration setting separate. So net.ipv4.ip_forward equals 1. And then since we are also doing the IPv6, then you would do the same thing for the IPv6. You don't have to do this if you are not using IPv6. I do not. So that's that. Now we will do sysctl-p. And I think we need to include that file, but we'll just say, let's check if it is. Nope, it hasn't been. So we'll do sysctl.d wireguard.conf. Okay. So now if we grep for the forwarding, IP_forward, I guess. You can see that the IPv4 forward is set to 1 and it's enabled. So that is all for the server-side configuration. What we will do now is I will show you how you can do the QR encode in. So let's say, also we need to just understand that the wz0.conf is the server config, the client01.conf is the client config. If you are on Windows or any other operating systems that you cannot use QR encode to create the config file, you would have to copy that file. We'll just show that in a second. But if you have mobile devices that allow you to do the QR code, you will see that when you install the WireGuard client, you will see that you have the option to scan the QR code. So in that case, you can do, I guess we haven't installed the QR encode, so we'll install QR encode. Okay, once we have the QR encode, what we can do is -t ncutf8 is, we're going to type client01.conf, and then you get this nice QR code that you can scan with the mobile application. So in case you don't have that, we would have to client01.conf, we would have to copy this. And let's say here, we will create, let me open up. All right, so here we're going to, oops, looks like I did not copy. Okay. Careful when you copy. Save as desktop, I'll say WireGuard VPN.conf. Save that. Now we have to download the WireGuard tool. WireGuard installation. If we go to the installation, you will have the WireGuard. Before that, let's just check my IP here. So this is my IP address, and we will see when I do the WireGuard installation and connect to the VPN, then we'll see what the IP looks like. Okay, so import tunnels from file, desktop, wireguard.conf. Okay, so the server configuration, the WireGuard VPN configuration has been imported. The other thing that we haven't done yet is to start the server. So in order to start the service, we will do systemctl start wg-quick at wz0 is the configuration file name. So, all right, let's see what the issue is here. Systemctl status wz-quick at wz0, and it looks like I made a typo. So say wz0.conf, the interfaces, it should be interface. Just double check the client 01. It seems to be correct. Okay, so now let's go ahead and try again. Start WZ0, and the service is started. WZ quick at WZ0, and we can see that the service is running. And if I do the ifconfig, I can see the W0 interface is up with the 200.254 as the IP address. Now let's try to connect from the client side. So we have the VPN here. We activate. And as you can see here, you cannot probably see this, but I get a little notification that says the WireGuard has been activated. And we also see that we've gotten the 200.5/24 is the IP address, and everything is being routed. You can see all the config mapped to their respective values. So persistent keep alive, that's what we configured. Allowed IPs, that's our routing. And now if I go and do the seemyip.com, I should see my DigitalOcean server's IP, right? So if I do the, oops, my connection just got disconnected with this guy because I connected the VPN, but you can see here that the server IP is 165.227.52.211, and we have that IP address. As soon as I disconnect my VPN, then I would route back through my own internet connection. This is how you can configure WireGuard or as a VPN server, as your personal VPN server, and you don't have to worry about anyone else having your browsing data, or at least the connection data. So if you're interested, I would just give it a try. I hope this video was really useful and you learned how to configure WireGuard. If you did like my video, please like, share, and subscribe to my channel. And I will put some links in the description so that you can actually follow the text version of this video. And I will see you in the next video. Thank you for watching.